REST APIs are all about our routers exposing themselves. API is the name of the game. That's how we're going to access our routers and switches with all the new network automation stuff. Oh, it's so good. And specifically, we'll be using a type of API called a RESTful API. What does that mean? The term REST is actually an acronym. It's a mouthful, stands for Representational State Transfer. And, you know, there's the acronym right there. RESPECT. I don't know why that came to my brain. Okay, but what is it? You know, I like to think of it as a code, like a pirate's code. You ever seen the Pirates of the Caribbean? The damsel in distress, Elizabeth Swann, gets captured by the pirates, and to save herself, she says, "Parley, parley," which allows her to be seen by the captain. It's part of the pirate's code, and every good pirate, if you're a good pirate, a proper pirate, you go by the pirate's code, and that's the same thing with a REST API. In order for an API to be a proper pirate, to be a proper RESTful API, it has to go by a set of rules or guidelines. They're also referred to as constraints. There are 6 rules in the RESTful API pirate code. 1, it's got to be a client-server architecture. 2, it's got to be stateless. Got to have no states. 3, it has to be cacheable. Now I'm going to stop right there. These 3 right here are really the only ones we care about for what we're doing with network automation and for any exam we might take. However, there are 3 more, and I'll go ahead and jot them down here. The other 3. So 4, it must have a uniform interface. We'll actually touch on that one just a little bit, but not too crazy. 5, it's got to be layered, like an onion. I don't know. And 6, code on demand. Again, don't worry about these. Just know that there are 6. These are what they are. But the first 3 is what we're going to really just squat down and hunker down and learn. Squat down. We're not, no. So let's get these other guys out of the way here. And let's focus in on rule number 1, client server. What does that mean? Well, in terms of working with a router, I'm going to make him appear. There he is. When we enable the RESTful API, REST API, on our router, it is acting as the server. When we write a script or use an application like Postman to access the API, we are the client. This is an important guideline for APIs because it allows for portability and changeability of the client. So I could be a web UI, I could be a script, I could be just network chuck using Postman to access it. So when I make what's called an API call, I'm calling on this API saying, "Hello, tell me your host name." And he replies with, "Hey, I am Groot," or I guess root. Horrible joke. So no matter what I bring to the table to access this API, from the server's perspective, he doesn't have to change. He's compatible. He's good. That's the beauty of a client-server architecture, and that's the first rule of the pirate code. If they don't do that, then sorry, you're not really a RESTful API. You're not really a pirate. You're just some dude dressed up for Halloween. And by the way, the server can be a router. It can be a controller. It could be a website. It could be a lot of things. REST APIs aren't just for network automation or for just one device. The next fundamental rule of the pirate code is that the API must be stateless. When I think about this, I think about my interactions with Alexa. Okay, she's probably listening. I'm gonna go turn her off real quick. She's listening right now.
I'm always here at the ready.
Told you. Okay, she can't hear me. Most of my interactions with Alexa is stateless, unless you have follow-up mode on, but we're assuming you don't have that on. Which means when I make a request to Alexa, that one request has to contain everything she needs to respond to me. Meaning she can't rely on previous conversations we've had. Like I couldn't go, "Hey Alexa, who's the first president?" and then right after that go, "What's his birthday?" No, the next request would have to be, "What is the first president's birthday?" She would need all the information, the full context every time I ask her. That's also what a RESTful API requires. The pirate code, of course, right? It requires it to be stateless. The same principle applies if I interact with my router and I say, like, let's say I have a API request and I say, "Hey, router, what's the admin status of interface GI1, gigabit interface 1? And my router, like the good RESTful API it is, would reply, "Hey, it's down." What I won't be able to do is go, "Oh, well then, what is the description?" No, it won't do that because it won't keep track of this last conversation. That's not that. It's like it didn't happen. I have to say, what is the description of gigabit interface 1? I have to keep everything in context. The server is like 10-second Tom. You tell him one thing, 10 seconds later, he forgets who you are, and you have to introduce yourself again and go over the entire thing again. That's stateless. So the session state is completely the responsibility and only exists on the client. Server doesn't know who you are. Each time it's like a new conversation. And looking at number 3, your REST API must be cacheable or nah. When I say cache, it's going to work very similarly to how we deal with websites. So for example, if I mosey on over to my my CBT Nuggets trainer page, cbt.gg/networkchuck. When I go to this website, things that will be cacheable, meaning things that won't change very often, like my name, maybe my picture, those things just don't change. So the server will say, hey, this stuff you can kind of just put in your pocket. You don't have to keep asking me for it. Just keep it right there. That way you can save some time and some bandwidth. But other stuff, like down here, my list of courses, that's changing data. Like that, I'm producing courses and even now, and I'm going to keep changing that list. That's non-cacheable data, meaning, hey, the server's like, hey, don't hang on to that information. Next time you ask me for it, just go ahead and ask for a brand new copy because it could be different. Same thing applies with a RESTful API. It must have some sort of mechanism to say, hey, this is cacheable or it's not cacheable. For example, if I ask my router, say, hey, what's the host name? That's probably something that won't change very often. So it might say, hey, here's that host name. It's Obi-Wan Kenobi. Do I know how to spell that? I think so. And you can go ahead and cache that. But on the same token, if I ask for, let's say, interface stats for Gigabit Interface 1, that is stuff that's constantly changing by the second. So no cache, because when I check back, it's going to be different every time. So what's a RESTful API? Well, it's an API, but it goes by a certain pirate code. It has to obey some guidelines, some constraints to be considered a RESTful API. We covered 3 of those in this nugget. It has to have a client-server architecture, me being the client, the router being the server. It has to be stateless. It can't keep track of our conversations. Each request I make to that API interface has to be everything. It can't rely on any other conversation or cached information. Speaking of cache, it has to have a way, number 3, to say, hey, you can cache that or don't cache it. There were 6 total, but those 3 are really ones we care about. And then number 4, kind of bonus, we're going to talk about it in the next nugget. It has to have a uniform interface. I hope this has been informative for you, and I'd like to thank you for viewing.